Welcome to our Master of Engineering Capstone Project Showcase at UC Irvine. Our project title is Wildfire Analysis and Risk Calculation using Hardware and Software of Advantech.
Every year, the Southern California has been suffering from wildfire, and the fire destroyed many structures and caused a large number of money in damages. During this year, by the end of October, there have been more than 8,000 wildfires and contributed to the burning of nearly 2.5 million acres of land. Here is a video clip from ABC News about the California wildfire.
Over to California now, where wildfires have forced more than 8,000 people from their homes. The Apple Fire has now burned more than 20,000 acres in Southern California, sending smoke as far as Tucson, Arizona.
So what caused such frequent and dangerous wildfires? Mainly due to three natural factors. They are high temperature, low humidity, and high wind speed, which are the three data collected by our system.
This is our team. To develop the system, we use WISE and MLO together with different kinds of sensors to get and transfer the data to the Microsoft Azure cloud. The data on the cloud is analyzed by machine learning model and get back a risk factor. Once the factor is bigger than 0.6, the customer will receive the alert email automatically.
About our features, we have self-designed applications and models. We use eco-friendly 3D printing materials, and we use many powerful devices. Of course, the most important feature of our project is that it is a comprehensive Internet of Things system.
Our system can be divided into two parts. The first part is power supply. Battery is charged by both solar panel and AC to avoid the insufficient power supply. And battery will guarantee normal operation of WISE, Arduino, and wind sensor. The raw data will be collected by the sensors and then transmitted to the WISE through wireless and restored in the cloud database. This data will be processed in MIO to realize the machine learning via random queries. Finally, users will receive an alert message by email.
The machine learning part contains three parts. We collect 10 years wildfire incident data from Kaggle database and the Google Earth engine, combine them together based on their time and the coordinate information. Here we get the training data. Next, pre-processing the data. In this step, we are going to remove all useless or null values in case of the calculation error in the program. Then classify the fair class into a binary result. Here, for class A and B, we regard as no fair, as the burned area can be ignored. For class C to G, regard as fair happens. The model generation part is the core of machine learning. We use random forest algorithm. 80% of data used to training and 20% used to testing. With 10 times cross-validation, the mean RMSE is 0.25, and the predict value is the fair risk factor, which is a decimal between 0 to 1.
This is our prototype. We use a hexagon as the enclosure shape, which is very stable and practical. Then we use a tough and strong material PETG for 3D printing. The white color is chosen to reduce heat dissipation. There are ventilation grills at both lower sides. They can effectively dissipate the heat and prevent rain. The main enclosure can be fixed on the base and can rotate around the central screw. Therefore, once the base is fixed on the rooftop, they can still face the sun. Here is a little demonstration of how the system works. We get the inputs from the sensors. These data are uploaded and can be read by the users in real time. Once the fire risk factor shows on the right bottom is very high, you will immediately receive a warning alert email.
Here, I will introduce our project timeline, which have 4 stages. The first is about initial design and idea review. The second stage is about learning new knowledge and design improvement. Then the next is about prototype implementation and midterm review. The last stage is about final assembly and testing.
Here are the challenges which we meet in our project. The most challenging thing in my part is to research and compare different machine learning algorithms as well as develop the corresponding codes.
The most challenging things for me in this project are develop software for IoT system and learn a lot of new knowledge for it.
For me, the most challenging thing is that we need to collect the temperature and humidity from the DHT22 sensor and send them to the Azure cloud through the WISE digital inputs.
The most challenging part is that I have to learn a lot of mechanical skills from the beginning, since there's a mechanical major in our group.
The biggest challenge for me is to find the most suitable enclosure materials that can meet all those needs.
The biggest challenge for me is learning something about simulation on SolidWorks and acquire skills about mechanical design and calculation.
In the end, we are really appreciated for the supporting from Mr. Zhou Sanga, Mr. Wei Lun, Mr. Joseph, Mr. Andrew, and our faculty advisor Dr. Fazard, and all faculties from the Harrison Mill School of Engineering. Thanks for watching and hope to see you in the future.